study about the instruction set of 8085. In the instruction set, all the instructions which are supported by the 8085 microprocessor, they are included. So the instruction set of the 8085 and combines have all the instructions of 8085, and these instructions, they are divided into 5 categories. First is data transfer instructions, then we have arithmetic instructions, logical instructions, branching instructions, and machine control instructions. So let us study all the instructions of the instruction set of 8085. The instructions, they are divided into the 5 categories. So these are the 5 categories in which the instructions of the 8085 are divided. First is data transfer, arithmetic, logical, branching, and machine control instructions. First, we will start with data transfer instructions. The instructions in this category, they transfer the data from one location to another. That is, from source to destination, the data is transferred. But the content of the source, it is not altered. So we can say that it is a kind of copying operation, that the contents of the source, they are copied to the destination. First instruction under this category is MOV. This instruction, it copy the contents from the source to the destination. So here we have RD and RS. This is the source register and this is RD is the destination register. So the contents of the source register, they are transferred to the destination register. Also we can have memory and the source register, and we can have a destination register and a memory location. So there can be 3 types of operands in this instruction. In the first, if we have move RD and RS, then the contents of the source register, they are copied to the destination register. If we have M and RS, then the contents of the source register are copied to the memory location. The address of the memory location is specified by the HL pair register. And if we have RD and M, then the contents of the memory location are copied into the destination register. So what this instruction is doing, so we can have these 3 operands. RD was destination register, RS is source register, and M is the memory location. So this instruction is copying the contents of the source register into the destination register. The contents of the source register are not altered. That is, when suppose this is having a number 06, so this number will be copied to the destination register, but source register will still hold its content. It will be having 06 in it. Now, if one of the operand it is a memory location like M and M here, so its location is specified by the contents of the HL pair register. How we are going to get the address of this memory location? It will be specified in the HL pair register. Okay. If we take examples, then example of this instructions are, we have move A comma B. So the contents of the B register, they are copied into the accumulator. Also we can have move C comma M. So the contents of the memory location which is given in the HL pair, suppose it is given 8050. So this memory location will be having the data, and that data will be copied into the C register. So this is the first data transfer instruction. Next instruction is MVI RD comma data, or it can be M comma data. So this instruction is just copying the immediate data. Data is given in the instruction, and this data is moved into the destination register or into the memory location. Again, if the operand is memory, then the address of this memory location is specified by the HL pair register. So if one of the operand is memory, its location is specified by the HL register pair. If we take examples, then example of this instruction are MVI B, 57H, or it can be MVI M, 57H. H is here denoting that this number it is in hexadecimal notation, and MVI is move immediate data. So it is moving the data which is given in the instruction into the register B or to the memory location M. The address of this memory location is specified by the HL pair register. The HL pair register, suppose it is having 8050. So at this memory location, this number 57 will be copied. So earlier was move the data, move the contents of the register or memory to another register. Here we are moving the data to the register or memory. Third data transfer instruction is LDA, and the operand is a 16-bit address. This is our opcode, and this is our operand on which the operation has to be performed. This instruction is load accumulator. What it is doing, So this instruction is loading the accumulator with the contents of this 16-bit address. The address is specified in the instruction itself, and the contents of the source, they are not altered. Suppose we have a 16-bit address 8050, and on this memory location a number is being saved, and this number is we have as 24. So this number will be copied into the accumulator. So here the accumulator is going to get the same number 24. But the contents of this memory location 8050, that is 24, it is not changed. It will remain 24. So this instruction is loading the accumulator with the contents of the memory location. If we take an example, then we have LDA 2034, or we have LDA, any address, any memory, the 16-bit address can be here. So XYZ. So the contents of this memory location will be copied into the accumulator. Next instruction is LXI. This instruction is load register pair immediate. This I is for the immediate data, and we have the operand as the register pair and the 16-bit data. So this instruction is loading the 16-bit data which is given in the instruction into the register pair, which is also specified in the instruction. If we take an example, then example of this instruction is LXI H, 2034. Here in the instruction we have the register pair. This register pair is HL. In the 8085 we have the registers as B, C, D, E, H and L. These are the 6 registers present in the 8085, and these 6 registers form 3 register pair, B with C, D with E and H with L. So these are the 3 registers pairs. Now here we have H written, so this is denoting the HL register pair. So in this HL register pair we will have this 16-bit data 2034. So this instruction is loading the register pair with the immediate data given in the instruction itself. Next instruction is LDAX B, D register pair. What this instruction means, it is loading the accumulator indirectly. So this instruction is loading the accumulator indirectly. The contents of the register pair it point to a memory location. We have here the register pair B and D. HL register pair is not used. So B means BC register pair and D means DE register pair. So the contents of the register pair they point to a memory location. Suppose in BC we are using, so BC register pair will be having a memory location in it. Suppose we have 2034. This memory location is being saved in the BC register pair. So it points to a memory location. This instruction will copy the content of that memory location into the accumulator. Now at this memory location 2034 a number is being stored. Suppose 40 number is stored there. So this number will be copied into the accumulator. So 40 get copied into the accumulator, copies the contents of that memory location into the accumulator. Now one thing we have to note, the contents of either the register pair, the contents of register pair are the memory location and the contents of the memory location is having 40. They both are not changed, only the accumulator is having that number. This number is being copied into the accumulator also. So you can see that these instructions they are just transferring the contents or copying the contents. They are not changing the contents, picking the content from here and storing it at another place. They are just copying or transferring the data. So this was LDAX, that is loading the accumulator indirectly. Next instruction is LHLD. So this instruction is loading the H and L registers directly. HL is in the instruction itself, so you can remember that it is loading the H and L registers directly, and the operand is a 16-bit address. So this will be a memory location. So this instruction is copying the contents of the memory location which is pointed out by the 16-bit address into the register L and copies the content of the next memory location into the register H. Let's take an example. We have an example as LHLD 2050. So this is the 16-bit address which is denoting the memory location. So at this memory location, suppose this is 2040, we are having a number 3E. Now this number it will be copied into the register L and the contents of the next memory location. Next memory location is 2041 and suppose it is having 4F. So the contents of the next memory location are copied into register H. So if we have here the register pair HL, so L will have 3E and H will have 4F. So this instruction is loading the H and L registers directly because the address is given to us. Just the contents of this memory location, they are to be transferred or copied into the HL register pair. The contents of the source memory location, that is 3E and 4F, they are not altered, they remains the same, they are just copied into the HL register pair. So this was the LHLD instruction. Next instruction is STA 16-bit address. This instruction is store accumulator byte. So this instruction is store accumulator direct. So the contents of the accumulator, they are copied into the memory location specified by the operand. Let's take an example. We have STA 4350H. This is a memory location 4350. So the contents of the accumulator, suppose accumulator is having 5A, this is a number. So this number will be copied into the memory location which is specified by the operand. So operand is specifying this memory location 4350. So on this memory location, this number 5A will get stored. So we are storing the accumulator at a memory location directly because the address of that memory location is given in the instruction itself. Now this instruction, it is a 3-byte instruction. When we are going to save this instruction into the memory of the microprocessor, then for STA we will have a machine code, then for 43 we will have 1 byte, and for 50 we will have 1 byte. So 1 byte for this, 1 byte for 43 and 1 byte for 50. So this will be a 3-byte instruction. Now the second byte, when we are going to store it, then for STA, suppose we have a machine code like 46, we have a machine code for STA. Then we are going to store this 50. First the lower order address will be stored. So 46, then 50, and then the higher order address 43 will be stored. So in this way, this instruction will be stored in the microprocessor memory. So all the time remember that we have the second byte is specifying the lower order address and the third byte is specifying the higher order address. So this was the storing the accumulator directly STA instruction. The next instruction is STAX register pair. This is the opcode and this is our operand. This instruction is store the accumulator indirect. So this instruction, it is storing the contents of the accumulator into the memory location which is specified by the operand. Here the operand is the register pair. So the contents of the accumulator, they are stored in the register pair. But the contents of the accumulator, they are not altered. If we take an example, we have STAX B. So the contents of the accumulator, they are copied into the memory location which is specified by the operand. Now this is our B register, so it is showing the BC register pair. Now this BC register pair, it is suppose having the memory location 2034. This is BC. So the contents of the accumulator, suppose contents of accumulator are 20, so this content will be stored at the memory location which is specified by this register pair. So on 2034 memory location, this number 20 will be stored or copied. So this instruction is storing the accumulator indirectly, because the location at which the accumulator has to be stored, the contents of the accumulator are to be copied, they are not directly given in the instruction, they are given in the register pair. So it is an indirect addressing of the operand, so it is storing the accumulator indirectly. So this was STAX. Now next instruction is SHLD, and then we have 16-bit address. It means store the H and L registers directly. The address of the memory location is given to you, the 16-bit address. So this 16-bit address you have to store in the HL pair register. So the contents of the register L are stored into the memory location specified by the 16-bit address, and the contents of the H register, they are stored in the memory location just after this. So this instruction is storing the H and L registers directly. That is, the contents of the H and L registers, they are directly stored at this 16-bit address. So the contents of the register L, they are stored at the memory location which is specified by this address, and the contents of the register H are stored in the next memory location. If we take an example, then we have SHLD 2470. So 2470, it is a memory location. This is 2470, and we have H and L register pair. Now this register pair is having a number in it. We suppose we have 30 and 20. Okay. So the L register, it is having 20, so 20 will be stored at this memory location, and at next memory location 2471, the H register pair is being stored. So it is saying that the contents of register L are stored in the memory location which is specified by this 16-bit address. that is 2470, and the contents of register H are stored in the next memory location, that is 2471. But the contents of the HL register pair, they are not altered. Now this instruction, when it is stored in the memory of the microprocessor, so it will be a 3-byte instruction. SHLD will have a machine code, then we will store 70 and then 24. The lower order address will be stored first and then the higher order address will be stored. So this will be a 3-byte instruction. 1 byte for SHLD, 1 byte for 70 and 1 byte for 24. So this instruction is storing the HL register pair directly because the address at which the contents are to be stored, it is given in the instruction itself. So it is a kind of direct memory addressing. Next instruction we have is XCHG, exchange. This instruction is having no operand in it, that is why I have written none here, and this is exchange H and L with D and E. We have the registers pair HL, BC, DE. So it is involving HL and DE registers pair. So operand and operation both is given in the instruction itself. So it is a kind of implicit addressing because the operand is already given in the instruction, that is exchange H and L register pair with the D and E register pair. So this instruction is just exchanging the contents of the register pair HL with the DE. If we take example, then in the example in program we just write the instruction XCHG. No operand has to be specified because it is given in the instruction itself. HL register pair, suppose it is having 8050 and DE register pair, it is having 9050. So these contents, they will be exchanged. Let's take here 9060. So we have HL register pair has 8050 and DE has 9060. So the contents of D, they are exchanged with H and H will come into D. Similarly, the contents of L will come into E and the contents of E will go into L. So when this instruction is executed, the new contents of HL will be 90 and 60 and DE will be 80 and 50. So this instruction is exchanging the contents of HL with DE. Okay. Next instruction is SPHL and it is also having no operand. So what it is doing, it is copying H and L registers to the stack pointer. So the contents of this HL register pair, they are copied to the stack pointer. There is no operand. Operand is specified in the instruction itself, HL and the stack pointer. So What does this instruction does? So this instruction loads the contents of the H and L register into the stack pointer register. Stack pointer register, it is a 16-bit register and it denotes the starting of the stack, that from which memory location the stack is starting. So it is defining the beginning of the stack. Stack is an array of memory locations. So suppose in HL we have the memory address 2034 and this memory address will be loaded in the stack pointer. Stack pointer is 16-bit. So this address will be completely transferred into the stack pointer register 2034. The H register, it is showing the higher order address, and L register, it is showing the lower order address. So we have the address as 2034 and at this address the stack pointer will be initialized. So the stack will start from this memory location. So if we want to execute this instruction, then we will just write the example is SPHL. Because there is no operand is specified in the instruction, so just write SPHL to execute this instruction. Next we have XTHL. So this instruction XTHL, it is also having no operand. This instruction exchange the contents of HL with the top of stack. So the operands are specified in the instruction itself, that you have to exchange the contents of HL with the top of stack. Now the contents of the L register, they are exchanged with the stack location pointed out by the contents of the stack pointer register. Stack pointer register, it is showing the beginning of the stack. So in the stack pointer register, if we are having 8050, so the contents of this memory location, suppose at 8050 we have 30 stored. So this will be exchanged with the contents of L register. HL register pair, suppose it is having 2034. So this location stack pointer is initialized at 8050 and this memory location has 30 numbers stored. So this will be exchanged with the L register. So now at 8050 34 will come and in the L register we will have 30. Now at the next memory location SP plus 1, that is at 8051, if we have suppose 21, Then this 21 will be exchanged with the H register. So 20 will come here and 21 will go there. So we will have 21 here and this 20 will come at 8051. So the contents of the stack with the top of the stack, that is at which the beginning of the beginning of the stack, that is the stack pointer register, so their contents will be exchanged with the HL register pair. So it is having no operand specified in the instruction. We have in implicit addressing mode here because the operand is specified in the instruction itself. So this was XTHL. Next instruction we have is push register pair. So this instruction is push the register pair onto stack. So this instruction is also related with the stack. So this push register pair, this instruction, it is used when we are dealing with stack operation. So the contents of the register pair, they are copied onto the stack. The register pair is given in the instruction itself. So if we take an example, so example of this is push B or push D. Okay, we can have any of the register pair here. So the contents of the register pair, they are copied onto the stack. How they are copied? Suppose we have in BC register, we have numbers stored there. Suppose 7F and 3E are stored in BC register pair. Then the stack pointer is decremented. Now in the stack pointer is showing us the beginning of the stack. Okay, the location from which the stack is starting. So here we have 8050. Now the stack pointer is decremented, so it will be decreased by 1. So we will have 80FF here. 8050, so it will be 8049 here. So stack pointer is decremented and the contents of the higher order register. Now we have BC register pair, we have DE register pair and we have HL register pair. So higher order registers are H, B and D. So the contents of these higher order register are copied onto that location. At 8049 we will have the contents of the higher order register B, that is 7F. Then the stack pointer is again decremented. So we will have here 8048. And the contents of the lower order register, they are copied to that location. So on C we have 3E. So 3E will be copied to 8048. So this is how this instruction push works. Push and then we have the register pair. It can be B, D or it can be HL register pair. So the contents of the stack pointer, they will be decremented. First the higher order register is copied and then the lower order register is copied there. That is C, E and L. Here B, D and H will be copied, and lower order we will have C, E and L. So this was the push instruction. Then we have pop instruction. So this instruction is also related to the stack operation. Here the operand is the register pair and it will pop off the stack to the register pair. So the contents of the stack, they will now go to the register pair. So this instruction, it pop off the stack to the register pair. The contents of the memory location which is pointed out by the stack pointer register, they are copied to the lower order register. Now suppose the stack pointer, it is initialized by the memory location 8050. So the contents of this memory location, suppose at 8050 we have the content 7E. So this content, it will be copied to the lower order register which is specified here. Suppose we take an example that we have pop H. Okay. So we have the register pair HL. So this stack pointer is having the address 8050 and it is storing 7E. So 7E will be copied to the lower order register at L. If we have B here and D here, then in C and E this content will be copied. Then the stack pointer is incremented by 1. So now the stack pointer will become 8051. Now the contents of that memory location. Now suppose at 8051 we have 5F. So this will be copied to the higher order register. Higher order will be, if we have BC register pair, then it will be B. If we have DE register pair, then it will be D. And if we have HL, then it will be H. So in H, this 5F will be copied. Now the stack pointer, it is again incremented by 1. So again this stack pointer will be incremented and now it will be 8052. So after this pop instruction, the contents of the stack pointer, they will be incremented by, first here it will be incremented and then again it will be incremented. So 2 times the increment is done. So we have 8052 as the last content of the stack pointer. So this is how the pop instruction works. It will copy the contents of the memory location which is stored in the stack pointer into the register pair. Next instruction is out. So this instruction out, it has the operand as an 8-bit port address, and this instruction, it outputs the data from the accumulator to a port with 8-bit address. So port address is given in the instruction itself, and the accumulator contents, they are sent to that port address. So the contents of the accumulator, suppose in accumulator we have a number 4F. So this number will be copied into the input output port, and the address of that input output port is specified by the operand, and operand, it is given in the instruction. Suppose we take an example, out 87. So 87 is the address of the port. So on this address, this content will be copied. So on 87 we will have 4F. So this is the out instruction. Next we have in instruction. So this instruction in, it also has an operand which is an 8-bit port address. So this instruction inputs the data to the accumulator from a port with 8-bit address. So the contents of the port which is having this 8-bit address, they are copied into the accumulator. So this is a kind of input, that is why we have written IN, and when the contents of accumulator are sent to the port, then it will be a kind of output function. So we use the out function instruction for that. So the contents of the input port which is designated by the 8-bit address, which is the operand of the instruction, they are read and loaded into the accumulator. So example is IN82. So it is the 8-bit port address, and at 82 if a number is stored, suppose 2A is stored at this at this port address, so this will be copied into the accumulator, and accumulator will get 2A here. Okay, so this was in instruction. This was the last data transfer instruction. So we have studied the data transfer instructions which are transferring the contents of either a register or a memory address, port address, or a stack into another register or memory location or into the accumulator. In these instructions, you can notice that the contents of the source register or the source location, they are not altered, they remains the same. So it is a kind of copy the contents from one location to another location. The next category of instruction is arithmetic instructions.